Hi class, today we are going to get a background about the periodic table of elements. Now I know it just looks like a crazy, not quite a box, not quite a rectangle table that we have hanging in our room, and each one of you have one in your lab notebooks. I would recommend that you have it around you now, which you should already because you should have a lab notebook with you whenever you're watching a video. But we're going to take a few notes on how it was put together and organized. But first, before we do that, I think we need to talk a little bit about the history of the periodic table. We have Dmitri Mendeleev, who is the father, known as the father of the periodic table, because he was the first one who looked at all of these elements, okay, things that exist in our nature, that he decided it needed to be organized in a specific way to help people understand more about these specific elements. He is a Russian chemist, and he worked back in the 1800s. The way that he began to organize the periodic table was he took all of the elements and he wrote their element or their chemical name and their atomic mass on cards. And what he did was he started to lay these cards out and try to create an organizational system. He thought what worked best was when they all were lined up based on their atomic mass, and he ended up putting them into a really long row. But what he found out was that row was way too long and not very user-friendly for people to work with, because as you look at the periodic table of elements, you can see that there's tons of them on there. However, back when Dmitri was working, he actually found there wasn't quite as many elements there, and let's talk about that for a second. So the long line wasn't working. So what he ended up doing was he started to create different columns. And you can see from the picture on the left here that there are gaps and holes in the periodic table that he originally created. And that was one of the things that he really discovered through his system. And these gaps helped chemists, helped other scientists and researchers to discover what would later fit into these holes. It was kind of the brilliance of the way that he organized his system. He organized it in a way that led to the fact that there should actually be something that would go in that hole, in that gap, an element that was to later be discovered. This led scientists to help make predictions about how they could go about discovering those elements. And as you can see here, okay, it shows the elements that were actually unknown to Mendeleev at the time and ones that were later discovered. So the way that Mendeleev had it originally set up was actually brilliant because it helped so many future generations of chemists and scientists to fill in the periodic table of elements. And you can see, and there's actually been stories, that there are still elements being discovered that have gone in some of these holes. It's quite amazing. So let's come back to our modern periodic table of elements. It has gone through some different transformations, and we're going to talk about a few of those transformations. This view is the most common view that is accepted by chemists, but it is by no means the only view of the periodic table of elements. But let's talk about how it's organized. It has two different organizational systems going on here. Okay, you can see that each box has a chemical symbol and a number in it. That number is its atomic number. Okay, and we'll talk about that here in a second. The first thing that I want you to pay attention to is that they are organized into groups, and each of those groups share a common characteristic. The groups are going up and down. So when we look here on the far right side of our periodic table with He, helium, neon, argon, all of those in that line are what's known as the noble gases. And that's probably the best example of the pure, everything in that column is and has a similar characteristic because they are all made up of noble gases. As you go across, you can see that each of those things do share common characteristics. And when you dive into the elements a little bit more, you can see how they're specifically organized, and I'll talk about that a little bit later. So that's one organizational system, the idea of groups. The other organizational system that's invoked on here is the idea of periods. Now, periods do not share similar characteristics, but they actually build on atomic number. If you read the table from left to right, you can see that it goes up by number. 1, 2, so starting with hydrogen is 1, going all the way across the table is 2, and they left that huge gap because even though that's how their atomic number is set up, hydrogen and helium really don't share anything in common other than the fact that they're a gas. As you can see, then going across to lithium, which is Li, 3 and 4, they build and they're a little bit closer in relationship, which is why they're next to each other. But there is that big, huge gap that is there for a specific purpose. But those are our two main organizational systems.